Check it.
Okay, welcome back. Today we're going into a couple more factoring methods. This is day 2 of factoring. All right, so the first new method is called the AC method. Now this is what you use when reverse FOIL doesn't quite work. And here's what I mean. For you to use reverse FOIL, you need to have a trinomial, like this one for instance, that starts with an x squared. Why? Because when you do your parentheses, you're gonna have an x and an x. And in the first step, when you go to multiply these, x times x gives you x squared. So if there's any number in front of the x squared, reverse FOIL doesn't work. Like for instance, a 6x squared or a 12x squared or a 16x squared. Right away that changes, and suddenly now you have all kinds of possibilities. Like for this 16x squared, x and x are not, when you multiply, they are not going to give you 16x squared. It could be 16x times x, which will give you that. Or it could be 8x times 2x, or it could be 4x times 4x, or it could be negative 4x times negative 4x, or negative 8x times negative. All of a sudden you have all of these combinations of possibilities and permutations, and it makes it 100 times more complicated, all right? Unless you get lucky and it turns out to be an easy question. So you only want to use reverse FOIL when there's nothing in front of the x squared, meaning the coefficient of x squared is 1. If you have any other number in front of your x squared, then you want to use this next thing I'm going to show you. It's called the AC method. The AC method basically changes your trinomial into 4 terms, and then you can use something called factoring by grouping. The AC method refers to this. This is in what's called the standard form of a quadratic. Ax squared plus bx plus c. So that's called standard form. A, b, and c are all whole numbers. A is positive. So this is a standard form expression. And so you know what your A is, you know what your B is, you know what your C is. And the AC method, this idea of an AC method, is that you're going to take the A and the C, which are 6 and negative 6, and you're going to do something with them. Okay? And this is going to help us avoid using reverse FOIL when reverse FOIL is complicated and doesn't work quite well. So here's what we do. We look at the fact that A is 6 and C is negative 6. And what we're going to do is we're going to multiply those two numbers. So that's why it's called the AC method. You're going to multiply A times C, and you get negative 36 because A is 6 and C is negative 6. You multiply those. Now, if you remember in reverse FOIL, you took the last number and you said what 2 factors of the last number will add to give you the middle number. Well, with the AC method, you're not using the last number, you're using A times C, but you're using it in the exact same way. Meaning, what 2 numbers multiply to give you AC, but add to give you the middle number here. So you need to find 2 numbers that multiply to give you negative 36, but add to give you positive 5. Okay? So it's very similar to reverse FOIL in the sense that you're doing the same strategy, but how you use those numbers is going to be different. So what are factors of 36? Well, there's 36 times 1, and there's 18 times 2, and there's 9 times 4. There's 12 times 3 I skipped over. There's 6 times 6. There's all kinds of factors of 36. However, only one set of factors is going to have either a sum or a difference of 5. This obviously doesn't work. This doesn't add or subtract to 5. This doesn't add or subtract to 5. This doesn't add or subtract to 5. This does. Okay, 9 and 4. If you subtract them, you get a 5. If you add them, you get a 13. So this is, you should go with the pair that has either a sum or a difference of the number you're looking for. Okay, which is the center number here. Now, you need this to be negative 36. If it's negative 36, you're going to have one of these be a negative number because you need to multiply them and get negative 36. So it's either negative 9 and positive 4 or positive 9 and negative 4, just like with reverse FOIL. And once again, which one will give us a positive 5? It'll be this combination here, positive 5. Now, we know that we're going to use 9 and negative 4. But what's different about this from reverse FOIL, we're not going to put parentheses down and put x's down and put a +9 and a -4 like we did before. It's not quite that simple. Okay? Here's what we're going to do. We're going to take that middle term here and we're going to split it into two terms. Okay? The two terms will be 9x and -4x. Now, that's what we use these two numbers for. Now, why do we do that? Well, the 6x squared stays 6x squared. That doesn't change. And the -6 on the end, that doesn't change. The only thing that changes is that the middle term now becomes two terms in this particular fashion. Now, it doesn't matter, by the way, if you happen to write the -4x and the 9x in the opposite direction. It doesn't matter. You get the same answer. But it's important that you're using 9 and -4, not some other combination of numbers. Now, once you've done this, you've taken three terms, a trinomial, and you've rewritten it into an equivalent quadnomial, 4 terms. Okay? 1, 2, 3, 4 terms. Now, you might say, well, yeah, but if I combine like terms, I go right back to this. That's true. But here's the thing. When you have 4 terms, you can do something called factoring by grouping. And if you factor by grouping, factoring by grouping is a strategy that requires a groupable number of terms. So 3 is not groupable because you wouldn't have equal groups. Like, for instance, if you took like 2 and 1, that wouldn't be the same number in each group. But with 4, you can take 2 and 2. A group of 2, a group of 2. So we're going to group together the first two terms. We're going to group together the last two terms. We're going to do factoring by grouping. That's all the AC method is. It's changing a trinomial, 3 things, into 4 things so we can use an entirely different factoring method called factoring by grouping. Now, we're going to get more deep into factoring by grouping in chapter 6. Right now we're in chapter 5. But for the time being, let's just do like basic factoring by grouping for the sake of doing this AC method. So the AC method part is actually done. All right, we took AC, right? Instead of using the last number in the trinomial, we used A times C, the first and the last. We multiplied them. We got our two numbers. We created a 4-term polynomial here. And now we're going to do factoring by grouping. Okay, how do you do factoring by grouping? Well, you take the first 2 terms, you make a group out of them. You take the last 2 terms, you make a group out of them. Include the signs, by the way. And here's what you do. For each group, find a GCF. What's the greatest common factor in these 2 terms? Well, they all have a factor of 3, and they all have an x. So do that. Factor out the GCF from both of these. If you do that, you get you have a 3x here, not just a 3. 3x, okay? 3x comes out of here, 3x comes out of here. What's left is a 2x and a 3, like that. Check it. Does this become this? 3, yes, it does. That checks out when you multiply them back. Okay. Now, how about here? Okay. Well, what's the greatest common factor here? Well, it's clearly just 2, right? So there's no x's in both of them, just one of them. But both of these, 2 goes into both of these. So you could put a 2 here, and what's left inside would be -2x minus 3. Okay? And of course, you can't just leave a gap here, so you would put a plus here, and now you have this. Unfortunately, this is wrong. This is wrong. Why? Because when you do factoring by grouping, the thing that's in the parentheses has to be the same for all the parentheses. So this is 2x plus 3. This also needs to be 2x plus 3. It's close. It's -2x minus 3, but it's not 2x plus 3. So how can I fix that? Well, what I can do is realize that there's still a factor in common here. There's a -1 here and there's a -1 here. So if I divide both of these by -1, that creates another GCF that I can pull out, and this becomes a -2. Okay? So let me back up a step. Let me show you a shortcut to avoid this mistake, or this problem, as it were. So here's what we can do. We did the greatest common factor for the first one. Once you know what's in the parentheses for the first one, guess what? You need to have exactly the same thing here. Otherwise, none of this is going to work. So you can kind of assume that what you're going to get in the parentheses here is the same as here. And now just ask yourself, what number do I put here that will distribute to give you -4x minus 6? And that answer is -2. Okay? So basically, just to recap, you're going to do the greatest common factor for the first one. You're going to have something outside the parentheses, something inside the parentheses. Copy that set of parentheses over here and just figure out what number fills this in. And now there you go. You've factored out a greatest common factor from here, a greatest common factor from here. Your inside parentheses parts are the same. So guess what? That means that this term and this term now have a greatest common factor, which is 2x plus 3. So those two get taken out like that. And the stuff that's outside is the other term like that. And there you go. That's factoring by grouping. Okay. So that might have seemed a little intimidating at first, but as you practice it, it becomes easier and easier. So let's do the next problem here. We have 8x squared minus 10x minus 7. Now this one has an equal sign, so we're not just going to factor, we're going to use the zero product rule and solve as well. So if you don't have an equal sign, then you're not solving, you're just factoring. But if you have an equal sign, you're doing both. You're going to factor this side, and then when you're done, you're going to have to use the zero product rule and get some actual solutions going. And you'll have two solutions here. Okay, so do you use reverse FOIL? Do you do that like last time and put the x in the x? No, because there's an 8 here. Okay? If there was no 8 here, reverse FOIL would have been fine. However, the fact that there's a coefficient in front of the x squared means AC time. Once again, this is ax squared plus bx plus c. So my a is 8 and my c is negative 7. So you find a times c, which is negative 56. Now, the question is, what are two factors of this, negative 56, that add to give me negative 10? And once I find those, I'm going to use those to split the negative 10 into two parts. So what are the factors of negative 56? Well, there's 56 times 1. There's 28 times 2, right? There's nothing times 3, times what is 14 times 4, okay? There's 7 times 8, okay? So on and so forth. Well, I've already seen the winner. We want the combination of factors that will add or subtract to give me a 10. Well, 56 and 1 is not going to do that. 28 and 2 is not going to do that. But 14 and 4, adding them will give you 18. That's no good. But subtracting them will give you a 10. Ah, we have a winner. So we're going to use that. You just have to figure out what signs they are, okay? So with 14 and 4, they have to multiply to give me negative 56. That means one of them has to be negative before I multiply. So either the 14 is negative or the 14 is positive and the 4 is negative. Either way I multiply these, I get negative 56. But which ones will add to give me negative 10? It's not going to be this one because this will give me positive 10. It's going to be this one right here. Negative 14, positive 4. And that's what you're going to use to split the negative 10x into negative 14x plus 4x. And you can see when you add these, you definitely get negative 10x. Once again, if you put these backwards, put the 4x first and the negative 14x second, doesn't matter, same answer. So you've successfully taken the middle term and made it two terms. The outside terms here are going to remain the same, okay? And this is still equals 0, write complete sentences, keep your equation intact here. And now you have a situation where you can factor by grouping. You have 4 terms. Let's just take the first 2, find the GCF, take the last 2, find the GCF. That's factoring by grouping. So what's the greatest common factor for these first 2 terms? Well, there's an x in both of them, and there's a 2. 2 goes into both of them, so 2x. And then you do your parentheses, and now you divide everything by 2x, you get 4x minus 7. Double check. Does that equal that? Yes. And does that equal that? Yes, when you multiply, yes. Now, what I told you above, the kind of pro tip I gave you was, for this to work, when you do the greatest common factor on this side, you have to have the same thing in the parentheses as this. So right away, just assume that, you're not going to make any mistakes. Take this and copy it over here right away. And now ask yourself, what number would I put here that I would distribute? What number would I distribute times these two to get this? Well, they're the same. So the only number that will work here is 1, positive 1. Okay, and yes, you must write the 1 in this case. So, and this is still equal to 0, by the way. So there you go. All right, 2x times these will give you this, and 1 times these will give you this, because these are the same. Now, here we go. Since we have 4x minus 7 in both of these terms, that's a common factor. You're going to take that out. And then the only thing that's left in the other set of parentheses is the 2x and the plus 1. Okay, hopefully this is making a little more sense the second time you saw it. And there you go. You factored this into two binomials, and you have the equals 0, so you're ready for the zero product rule now. You're ready to solve using the zero product rule. And the zero product rule says if you have a factor times a factor equals 0, whether it's 2 or 3 or 10 factors, doesn't matter, you can set each factor equal to 0 and solve. So let's do that. 2x plus 1 equals 0, and 4x minus 7 equals 0. We're going to get fractions for both of these. That's okay. Leave them as fractions. Do not change them to decimal. We do not use decimals in Algebra 2. The only time we ever see decimals in Algebra 2 is if the problem gives you decimals, but you never create decimals yourself. So for this one, we'll just subtract 1 from both sides. We get 2x equals negative 1. Divide both sides by 2, and we get x equals negative 1/2. There's one answer, not 0.5, 1/2. And now for this one, you want to get rid of the 7. You can add 7 to both sides. This becomes 4x equals 7. We want to get rid of the 4 now. Divide both sides by 4. Those 4s look a little sloppy. 4. And you get x equals 7/4. And that's it. Those are your two answers. That's the AC method. Let's do one more. Now, in this case, you see a 36 here. Right away you say, okay, I'm not going to use reverse FOIL because there's a number here. But also, you're supposed to, like I said in the other lesson, always, always, always check for a greatest common factor before you start. Now, there was no greatest common factor on the last two problems, but there is here. They all have an x in them, and they all have a 3 in them. If you try to do reverse FOIL with this now, it's either going to be incredibly hard or not possible. So pull out your GCF always, always. It makes your life so much easier. Now, the GCF appears to be 3x here, because there's an x in each one of these, so you got to pull out an x, and every one of these is divisible by 3, so divide by 3. Now what's left inside after you do that? Well, let's see, divide this by 3, you get 12x squared. Divide this by 3, you get negative x, and divide this by 3x rather, you get minus 1. Okay, double check. Distribute these. Do you get this? Yes, you do, but you should check. All right, so now I have this. This, okay, is going to require the AC method. So I'm going to leave this alone for a moment, come over here, and I'm going to do the AC method with just that part right there, okay? So let's work on that. Okay, so what's A and what's C? This is ax squared plus bx plus c. My A is 12, my C is negative 1, so AC is negative 12. I need two numbers that multiply to give me negative 12, two factors of negative 12 that add to give me negative 1. So you can think about the factors of 12, okay, without worrying about which sign is which. 12 times 1, right? 6 times 2, 3 times 4, and that's pretty much it, right? So which ones of these have either a sum or a difference of, this is negative 1 here. We don't write the 1, but there's a 1 there, right? Which ones will either add or subtract to give me a 1? Well, 12 and 1 give you 13 or 11. That's not going to work. 6 and 8 and 2 will give you either 8 or 4. That's not going to work. 3 and 4 will give you either 7 or 1 if you subtract, right? It's 7 if you add them, negative 1 if you subtract them. There you go. That's going to be your winner here. However, you need a negative 12. That means that either the 3 or the 4 is negative. So either it's negative 3 and positive 4, or positive 3 and negative 4. Which one of these sums, if you add these, which one will give you a negative 1? It's going to be the bottom one down here. 3 and negative 4, 3 minus 4 is negative 1. So you're going to split this into, instead of negative 1x, it's going to be positive 3x minus 4x. And if you think about it, 3 minus 4 is negative 1. It works perfectly. Bring down the other things, and now you have your 4 terms for the AC method, for factoring by grouping. So once again, here we go. Take the first and last term, first two terms and last two terms, find the greatest common factor of the first two terms. So parentheses, what goes out here? Let's see, 3 goes into both of these and x goes into both of these. So definitely 3x. And now when you pull out the 3x from here, you get 4x, and you pull out a 3x from 3x, it's just a factor of 1. Double check. 3x times 4x is 12x squared? Yes. 3x times 1 is 3x. Yes, that works. Now, before I even look at this, I know my parentheses on this side have to be what? 4x plus 1. Right away. And now I just have to ask myself, what number do I put here that when I distribute it gives me this stuff here? And you can see that this is negative 4x minus 1, which means I need a negative 1 here. If I distribute negative 1 times that and negative 1 times that, I do get these. So now finally you can see this is a 4x plus 1, this is a 4x plus 1, that's going to come out. And the outside stuff is just 3x minus 1. There you go. That's factored by AC method. So bring those and replace this with that. So this is now 3x minus 1, 4x plus 1 equals 0. We have 3 factored terms. We have a 0. We can use the 0 product rule. That means all the factors. And don't forget, this first one here, even though there's no parentheses around it, it's still a factor. Set it equal to 0. Set this equal to 0. And set this equal to 0. So, because if A times B times C, if 3 things multiplied equals 0, one of them, 2 of them, or all 3 of them have to equal 0. Now, next year in pre-calc, they'll actually be somewhere one is equal to 0, but one is not. But you'll worry about that later. Right now, we're just going to assume they're all equal to 0 and solve for all of them, and that's going to work fine. Okay, so 3x times 0 equals, 3x equals 0 means x equals 0. Here we have 3x minus 1 equals 0, so we'll have to solve that. And here we're going to have 4x plus 1 equals 0. We'll have to solve that. So like I said, x equals 0 for this one. Here we're going to add 1. We get 3x equals 1. Divide both sides by 3. We get x equals 1/3. Okay, divide by 3, divide by 3. And in here, we're going to subtract 1. You have 4x equals negative 1. Divide by 4, divide by 4. And we get x equals negative 1/4. And those are our 3 answers right here. And there you go. That's the AC method. So let's talk about a difference of squares. When you multiply 2 things called conjugates, 2 binomials that look exactly the same, but the only difference between them is that one has a plus and one has a minus. So you have a binomial and a binomial. And if they're the exact same binomials, but they have a different sign in the middle, they're called conjugates. So an example would be like 5x plus 7 and 5x minus 7, right? Or x plus 3 and x minus 3. Those are all conjugates. Okay, conjugates, like you think of them as like partners, okay? And if they are almost exactly the same except for the sign in between, when you multiply them, something interesting happens. Let's go ahead and multiply these. 2x times 2x is 4x squared. 2x times negative 3 is negative 3x. 2x times negative 3 is negative 6x. 3 times 2x is positive 6x. And then 3 times negative 3 is 9. And what happens all the times when you multiply 2 conjugates is that the 2 middle terms are going to cancel out, guaranteed. And what you get is this. And this is called a difference of squares because, first of all, when you have something minus something, that's called a difference, right? Subtraction is a difference. Addition is a sum, multiplication is a product, and division is a quotient. This is a difference. And it's a difference of 2 things that are perfect squares. This 4x squared is 2x times itself. And this 9 is 3 times itself. So both of these are perfect squares, and there's a minus in between them, so they're a difference of perfect squares. They're a difference of squares. And anytime you have a difference of squares, you can factor them backwards into conjugates again. Okay? So difference of squares come from conjugates. And well, if you know that, you can go backwards. So here we go. We have what looks like almost the same expression here. We have a difference of 2 things, and they are both perfect squares. What do you square to get 9x squared? 3x, right? Because 3x times 3x is 9x squared. So this is really a perfect square, 3x squared. And what do you square to get 4? 2 squared. So this is a difference of squares, right? It's 3x squared, the whole thing squared, minus 2, the whole thing squared. Once you realize that this is something squared minus something squared, that it's a difference of squares, you can just write your answer, okay? This is going to be 3x minus 2 and 3x plus 2, and you're done. Difference of squares, very, very easy to factor. Okay, for this next one, we have an equation, All right, and in order to solve an equation, you always have to have a 0 on the right side anytime you're solving an equation with factoring, because the zero product rule, you need a 0, right? So we'll start off by getting rid of this 28 by subtracting it. We'll have to subtract it from both sides. And now we get 2x squared minus 98 equals 0. And you look at this and you go, okay, is that a difference of squares like the ones we've been doing? And the answer is no. 98 is not a perfect square. You can't square root 98 without getting, a decimal. And 2, you can't, something times something is not going to equal 2 either. So it doesn't look like you can do this. However, you have to remember the golden rule here. Always check for a greatest common factor before you factor anything. Okay? Check for a GCF before factoring. So is there a greatest common factor here? And the answer is yeah, 2. You can take a 2 out of both of these. So take the 2 out of here. And now this is going to be just x squared. And this is going to be 49. Now look at it. Is that a difference of squares? Yes, it is. What's being squared here? An x. What's being squared here? A 7. Right? So x squared minus 49 is x being squared and 7 being squared. So how do you factor that? Simple. It's x minus 7, x plus 7, or x plus 7, x minus 7. It doesn't really matter what order you write them in. So that means that is going to be the factorization of that. So 2 times x minus 7, x plus 7 equals 0. The fact that there's an equal sign there means you have to solve. You have to actually keep going now. This is fully factored on this side, but when you have an equal 0 and they tell you to solve, you need to do this. Zero product rule. Everything equal to 0. You can see that this is going to give you x equals 7. This is going to give you x equals negative 7. And this is not going to go anywhere because 2 does not equal 0 and there's no x to solve for. So you're done. And that's using a difference of squares to factor. So before you could see the difference of squares, which is super easy to do. Once you know it's a difference of squares, it's really easy. But before you can see it, you had to pull out the GCF so it becomes visible. Okay, and that one's done, and we are done. Just remember that you keep factoring until you cannot factor anymore, and then you do your solving, okay? And always check for a GCF first. See you at the next video.
Check this.